Okay, so hey guys, in this video we are going to continue with our Golang with Scratch series, and in this video we are going to dive deeper into net/http package, explain HTTP handlers and request routing, and the main goal of this episode is to go deeper into understanding how Mux works and how multiplexer in this request work. So this is something that you are not going to use a lot in doing majority of your projects, like 80% of the time you are not going to go into this, but it's really important to know how the request routing happens in the background, and this will allow you to handle those 20% of the cases where you are going to interfere with this thing. So if I have to do a complete background of this, we are going to define a custom handler using http.handler function, which I have defined in the last episode 1, and we are going to do a lot of recap in here, and you will find that a lot of content comes here, so I'm not going into depths of that and would be introducing you to the new concepts. And I'm going to explain the ServeMux function and default mux routing. Then we will walk through the response writer and request struct basics, and we are going to implement multiple endpoints, which would be just to explain you how it's all working. We are going to work with status codes and all. So yeah. To get started, I would like you to remind that this is something that I am doing very candid, and I'm going through the process where you can, I'm going to go on to the documentations and follow you to understand what's happening in the background. When you're doing production level, you can go ahead and use a lot of AI tools, and that is perfectly fine unless and until you understand what's happening in the background. But I think for the learning purposes, it's much better to go ahead and go ahead and read docs with me. And as I always say, that if you have to learn something new, anything, it's always better to go one abstraction deeper and understand what's happening below it, so that you can have a total grasp and handle those 20% of edge cases that are going to happen with you. So to get started, I will go on to my terminal, and this is my KT terminal, and I'm going to use NeoVim. In case you see any kind of error into my editor, that's probably me and my Lua code, so you don't have to worry about that. It's not going to affect anything. So if I do ls, you can see that I have a go.mod file and a main.go file, which is something that I have defined in the episode 1, so I'm not going into the depths of this. So I will just fire up my main.go file, and this is the error that you will see. It's a linting error, which is not on your part and will not affect anything. It's my code editor. So what I will do is go ahead and do package main, because this is my main package of my Go file. And to start with, I'm going to import a few libraries, which are the standard ones which we are focusing in this series, and I'm going to import the net/http. Now the format library is something that would be used for string manipulation, and the net/http is our main library, which we work with for writing our handlers. So what we are going to do is, we are first going to create a custom HTTP handler. Then we will understand how request routing works with ServeMux, and I will be going to expose you to how everything works in that site, and go on to the documentation. I will expose you to the documentation. You can go ahead and read it, because it would be probably much better that you will go ahead and yourself go ahead and get your hands dirty with reading the documentation. There is nothing that I can explain it right here, but my job is to just go ahead and expose you to that. Then we are going to go into understanding response writer and request structs. This is something that I have already explained you in the episode 1 and got deeper into that. So yeah, you can go ahead and watch that, and of course we are going to implement some endpoints for understanding. So after importing my libraries, first of all, I am going to create a custom HTTP handler. So to get started, I will declare a struct which will be called home handler, which is an empty struct. Then I'm going to declare a function called, I will call it h, and have it with the struct home handler. So you can attach this to the struct which we will be declaring, and we will be doing all the operations into there. So we will have call it serve HTTP, and we are going to do the usual stuff, like we will be calling the response writer. We will be taking our parameter as a response writer, where we will be writing the response, and we will have the http dot request. This is something that I have explained in the last video, so you can go ahead and check out if you have any confusions in that. We are going to call the format library, and we are going to do the f println so that I can print the message into that response writer. Just a basic stuff to return a response. We will say welcome to Go server, and here we have implemented it. So to summarize this, we define a home handler, which is a struct. It implements serve HTTP, meaning it qualifies as a HTTP handler, and then we have a response writing into the client with this fprintln. So now let's have this handler into our main function. So now this part is to set up ServeMux and routing. So Go provides http.servemux, which is a request multiplexer for routing different URLs. Let's create multiple routes for this. So now I'm going to declare a func, which is the main func, and this is all the execution part. This is where our code will start executing once it's a binary. So first of all, I'm going to go ahead and declare a mux, which I would be calling it from http.servemux. Let's have it as a new ServeMux, and we will go ahead and understand what it does. If you see on this screen right here, my language server is saying me that a new ServeMux allocates and returns a new ServeMux. So ServeMux would be a struct on its side. So I will first call it, and we have declared it now, and let's go on to the documentation for that. So this is the documentation for ServeMux. You can go ahead and search for ServeMux, new ServeMux, and you will find it here. So new ServeMux allocates and returns a new ServeMux. Okay, that's good. It returns a ServeMux, but let's see what ServeMux does. So we are going one abstraction deeper into this. Now, a ServeMux, I will open it on a new tab to just go ahead and understand it. But what it's really doing is an HTTP request multiplexer. A ServeMux is a HTTP request multiplexer, and it matches URL of each incoming request against a list of registered patterns and calls the handler patterns, which closely matches the URL. This is something that I'm going to explain you in depth on my editor, but let me just tell you about this. What is a pattern? A pattern is something which has a host and a path. So you have a path called index/html. Now in the olden days, when backend engineering was like you just have to deploy on Apache Nginx and have some couple of HTML files being served into there. Now we do kind of dynamic handling in here. So if you have an index.html, you're not going to directly serve that index.html and give a file to him on the browser itself to run. What we are going to do is we are going to get this index.html and we are going to pass it to a handler which is capable of handling index.html, and it is the part where every kind of manipulation will happen. Like here is the case where there is a handler right here, and we have declared a handler here which our handler also looks like this, which has a HTTP response writer and request, if you have seen in the last video. So a handler is capable of handling any kind of request if it matches the pattern. Like if you have a pattern of index/html, and if the ServeMux routes that request to that handler, it is completely capable of managing it because it has been implemented for that stuff. So if you'll go ahead and find the real meaning of this, because okay, it's all good that you are going to have index.html routed into functions, so you can do advanced capabilities, you can log the request, you can push that into a data pipeline, you can have logging into that. But things get really interesting when you play with REST principles, which we are going to study in the next few upcoming lectures. But in this case, you have a GET request, and it's going to the /static file, and now it will match the GET request and whole part that ends with the statics, which is well enough. But if you have a POST request, then what you are going to do? In that case, if you have a normal directories into your web server and you are just working with usual traditional old backends, there will be no routing. You send a POST request, it is going to deny that it's not going to work. But in our case, if we have a GET request, we will call another handler. But if we are giving a POST request, we are going to call another handler. Like for example, I will comment this out and explain you in here. So I have an endpoint called /Pokemon. So if I have a Pokemon and I have to create a Pokemon, like this is my endpoint. I will name it as an endpoint which I am desiring. And now I want to create Pokemon endpoint, but I don't have to declare something like this. because this is something that I would be creating and one more endpoint is added and I'm really bored with this, I want to try something new. So if you want to create a Pokemon, it would be better to have a post request and then call the Pokemon endpoint where you can create a Pokemon. Then if I want to fetch all the Pokemons, I can do get/Pokemon, which gets all the Pokemon. And if I want to delete a Pokemon, then I can give a delete request to /Pokemon and it deletes the Pokemons. But this thing with this is, now since you're seeing here that you have the same endpoint, like if you have /Pokemon, then how will the backend know where to route everything? Like what I want is, if I give a post request, I want the backend to route it to something like create Pokemon handler, where it will be handling everything related to creating a Pokemon. Because in this case, you are going to do a lot of things. Like if you are creating a new Pokemon, you are going to log it, like which users likes to create which kind of Pokemons. You are going to have it into your database. You are going to store them. You have to log the user for business requirements to get analytics on that part. Then if you have this, then you want it to go to the get Pokemon method, where it is going to handle how to handle the Pokemons, and we are going to have the delete Pokemon, where you are going to handle deleting the Pokemon, and you have to make this request. Now you are seeing that the resource is same, the /Pokemon is same, but you are having a post request and now you want to go to create Pokemon so that you can create it. So this is something that is handled by the ServeMux. So this is a multiplexer. So if you're familiar with electronics, if you have worked with electronic systems, you have multiplexers and demultiplexers where digital logic has been routing to different parts so that you can reduce the number of bus lines into that. It is the same here, it's the same analogy. You have multiple options to go into it and you have limited options of getting out of it. So yeah, multiple options to route it to where you want to route the traffic itself. So this is something that has been explained here, and again it would be really awesome if you can go ahead and read everything of this in your own time. Study about this, about how sanitization and everything works. This is something that you are going to use in production level backends a lot and would help you into doing a lot of stuff, doing a lot of advanced routing onto that part. So yeah, now what we will do, let's go another abstraction deeper. Now what we are going to do is to go ahead and understand the ServeMux. So what ServeMux struct is doing. So you have this sync RW mutex. Again, mutexes are going to be explained in this channel. It is more advanced into concurrency and all. So we are not going to go here. This is the routing node and this is the routing index, and we have the mux. So again, what you should do is you can go ahead and this is just a struct. Okay, a struct is just a collection of data types, and here I think this is a tree. I also don't know what's happening beyond this. It's a routing node and there is a routing index. Now I can imagine a lot of stuff what might be happening in here, because I can see a routing node and it is giving me some hints about trees. There might be some trees that are doing this, and there are index and we have routing index. So I will go ahead and search about where it has been defined already. This is something, okay, routing node, and I will go routing node where it has been defined. There is a var n routing node here. It is also defined in here. It is also defined in here. It has also been called in here. So this is something I think has been called from an external library, which must be declared somewhere else. It might be somewhere here, but again you can go ahead, and if you have more interest into that, again you don't have to go this deeper unless and until you're working with the Go programming language into the depths and building it. But it's really awesome to know this, and it will give an edge over other Go developers who don't know this stuff about how this routing and all is happening. So okay, what I will do is as usual, let's go ahead and declare handler. Now I will call the multiplexer the mux part, and I will say it should handle something. Now let me go again into this. Okay, and I will go to the ServeMux part. ServeMux struct. Okay, we are back here. So yeah, here what we are going to do is HTTP new ServeMux has been allocated to this, and we are going to call mux.handle, and we are going to give it a route which is slash, let's keep it just normal one, and we will call it home handler. Okay, and again it's a struct, so it can handle this home handler. And then we have mux dot handle func, and we are going to go ahead and let's have it hello. And then again here you can declare and call another function. In the last videos we have defined that function handler into the starting of the file. I usually recommend that you go ahead and create different modules, and you create a module called as a handler, and then write all your handlers there so that you can edit all the handlers in that file and you can route it into your main function. But here we are going to do it directly, and sometimes it also helps you understand things in deeper, like okay, at the end this is something that is going to route into this handler, and this handler will have http dot response writer, and this is the response writer, and you have the star http dot request, and then you are going to have this part where you are going to call the format library, and you are going to do fprintln so that you can pass the message which will be hello world to this thing. And then we are going to do this again. It is saying mixed name and unnamed parameters, so I will check this out. Okay, there is a multiple this thing. I will go ahead and do this. There is a dot in here. This is now w http dot response handler, and this is a http request. Fine. We have to go ahead, let's declare another one, but this time we are going to handle a status code for this. We will do slash status. Now in this part you will learn how to respond with some status codes. So we are going to have a func, then we are going to do some http, again the same thing, the repetitive stuff, no need to explain, r, then you will have star http dot request, and then okay, let's go ahead and define it. So what we are going to do is, the W itself, which is the HTTP response writer, has a lot of stuff into it. Has like headers. If you go ahead and study, I will recommend this. I will write it in the comment. Go ahead and study about how request and response looks like. If you don't know about it, because it's out of the scope of telling you about how it works, but it is something that is very essential, and it will give you one level deeper abstraction how to request and so on work. So I want to tell that user who is calling me, I will tell him that okay, I will write a header for him, and that header will say that okay, http dot status code is okay. I will say it's okay. You can do anything here, like unauthorized access in case there is a user who is trying to access some resource that is unauthorized. You don't want him to do with it. It's all good. You can go ahead and do some unauthorized access, 400 status code and all. This is something that is logical, and we are going to build this logic as we go ahead with this series. So okay, we are just going to do a handle, sorry, not handle. I will go ahead and do a print f println. Again the same stuff, I would say w, and let's have a JSON response into here. You can use the JSON library, but in this case I'm not going to go into that depth. You can use it in your own time. This is a very small request, so we are just going to go ahead and do a status okay, and we will have a f println, and we are going to tell the user that we are going to have a server starting on port 8080, and then http dot listen and serve. This is something again I have explained in the last videos, and we will have it on 8080. And again, now the important part is in this thing we are going to route that request from 8080 port to the handler, which is the mux handler. So the mux handler is the multiplexer that we are going to route this. So to explain it in detail, I am going to have a part where I would say when the user calls localhost, for now when we are not declared, it will give a call to 8080, and that 8080, and it will have some resource, like it will have hello. So in this hello thing, it will go to the mux. The mux will handle it, and it will route it to the right handler, which I would say which is matched with the hello handler, and which has been defined in right here. So it is defined on line 25 It's defined on line 25, and it is going to call it, and then it will give the it will call the fmt library, will have print the hello world, glowrd, and then it is going to be responded to the user back. And this is how a life cycle of a request work in a very basic scenario. So okay, now we are going to go ahead and just do go mod clean, go mod tidy, sorry, because I was working with a lot of make files, and now it's clean. We didn't have to do that, but again we don't have any external libraries, but it's a good practice to do it, so I did it. So I will do go build, it will build the binary, and done, super fast as always, and I will execute that one, and it will have a server starting on port 8080. So okay, we will go ahead and then do some curl request into this. Now I will have a curl request. I will say that okay, the method is get, okay, the method is get, and then I will do some http/localhost, we will have the port 8080, and let's call it welcome to the Go server. Perfect. I will go back here, and it is the same thing. What we have done here is we also have defined a handler into here. So you can define a handler like this for your multiplexer. If you might have multiple multiplexers into this if you're working with some advanced projects, but in this case we just have one, and there are multiple ways of defining it. You can define it here, you can define it here, it's all good. So now we are going to go ahead, and this is something that is executed right now. It's working perfectly and I'm happy with it. Now we are going to call the hello handler. And again, we have the hello world here, which is from this part. We have declared it. This is one way of declaring it. Again, let's go ahead and call the status one. So what we are going to do is call the status handler. It's all good. You can get a JSON request, but let's go ahead and do some, go into depths of what's happening into here. So I will do /-i. What it will give is the whole response into this. So it has a 200 OK status code right now, and it has the date, it has the content length, it has the content type. This is something that is defined by it. You can again go ahead and edit this. It is in this case it's a status OK thing. It's a status equal to OK thing, and this is a JSON file here. And yeah, this thing is working perfectly. So now we are going to go ahead and do some response writer and request part. Okay, let's quit it down and let's quit it. Okay, now I'm going to do a quick write into here, and now we are going to understand response writer and request. So before we wrap up right here, we are going to understand a few things about response writer. This is something I have explained earlier also, but again let me just put a light onto it. The response writer is used to send responses back to the client. This is something you will have a request, you will process it, you will have a handler implemented, and it will process the incoming request and give an output. So this is something which will be done in the response writer. And w.write header. So in this case, you saw that we have w.write header which does status.ok, and you can define a lot of status codes into here. If you go ahead and if I just call my LSP, and you can do your status.text, accepted, bad gateway, bad request, conflict, continue, everything, forbidden, you can do anything. Forbidden is something when it's done when you don't want the user to get unauthorized access or something. You can learn it into the REST framework. We will go into the depths in the future. Then we have, you can go ahead and write w.write, where you can go ahead and write raw bytes into that. This is something I will explain it further, and most of the time you're not going to use it. Like if you can go ahead and do some real bytes. This is a very low level networking part, and I don't recommend you that you go that deeper into this in this stage of point. And again you have the fmt print ln which writes this response into this. And if you see the request part, again it has the same thing. You have r.method, you have r.url.path and everything. So what we will do here is, now we have a hello into here. Okay, now we'll go ahead and do some play around with request, like okay, what r is used for. So let's go ahead and have the fprintln, and what we'll do is, okay, it's hello world, and we will say that I want to give two parameters into this, which is r.url.path path, which returns the path that the user is trying to access, and we will also tell which kind of header is been sent. We will let's select a user agent. Which kind of user agent is the client using? In this case, you can have user can be using Chrome, Safari, Firefox, and depending upon what logic you have, you can have it here. So hello world, you are accessing this r.url.path and using user agent %s. So yeah, so this is format identifier. So what is going to do is it will copy this part r.url.path and substitute it into here, and it will have r.header. Get user agent, and it will be putting it into here. So let's go ahead and just remove this ln, because we don't want it to another line, we want it into here. And since we have removed the ln part, let's go ahead and do a /n so that we can append the request. We can have a new line after the request and don't end up in here. We will write it, go ahead, go build, successful. Then we are going to run it again. We are going to go in here, let's call the hello handler. Where is the hello ones? And then okay, now we have you are accessing /hello and using user agent curl. So yeah, I use the curl thing right here, but let's go ahead and get this URL and go into my Chrome and do it this way. So this says that hello world, you are accessing /hello and using user agent Mozilla, which is in Macintosh, Intel, Mac. This is not Intel Mac, but the browser is, I think, a bit outdated, and it has Apple WebKit like Gecko, and Chrome, it's Safari. It's his own thing, we don't mind about it. So what you can use it for? Imagine that you are building an e-commerce site or something, and you want that. This is something that legitimate people are doing right now, that they are charging more to the type of users they have. Like if they have a Mac user or anything, they detect that and they want to do different type of analytics onto how people using Apple products behave onto their part, and how those others who are using Firefox or using open source browsers, or those who are using Microsoft Edge, or all different kind of categories, all these people are utilizing this stuff. So this is something which is important for doing a lot of functionalities into that part. And yeah, this was the last thing that I want to say. And wrapping up, this was how custom HTTP handling works, and this is how multiplexes into Go library works. And we studied about the response writer and the request part, and this is how you implement multiple endpoints. So yeah, this was the second episode for the series, and I have been working on a lot of stuff right now, working on machine learning and system design onto that part, designing machine learning systems and all. So it has been really hard for me to upload a lot of videos right now. But again, I'm back into this, and it's probably good news for you, because I'm going to launch a lot of videos on how you can go ahead and do your own deploy own machine learning systems. And whatever I'm telling you here into this code itself, we are going to build our own machine learning agents, which are going to interface with the Kaggle notebooks. You can use a lot of models like DeepSeek, Olama, everything, and how you can serve your users and do a lot of data analytics onto that part. So this is something I'm learning right now and making use of it, doing it for multiple hours, like 12 to 13 hours, just working on the same stuff, and it has been really awesome. And I will be coming up with it soon. So for now, I'm just going to continue with this series, and hopefully that helps a lot. So bye bye.